Okay, this is Jason here again with another video for EEM 171, Codes and Installation. And what we're going to look at here in this video is talk about the panel where you'll get your source power from to connect to all your circuits that you're going to wire in the lab here. So I'm just going to pull this apart, point out a few things, and also go ahead and show you how to wire it up. Okay? So first of all, before you start wiring, again, make sure up above you that your disconnect is off. Okay? Pull the screws out from here, top and bottom, and remove the cover. Okay, and I'm just going to point out a few things here. So inside here, you see the wires coming in. That's coming from the bus plug up above you through the conduit into the panel here. And you have 4 wires. You have 2 black wires, a white wire, and a ground wire. Okay, so your 2 hots are to give you 2 different phases. Okay, so typically that would be in a residential application 120 to 40. Okay, so if you use one hot wire, that's 120. If you use both, that would be 240. Okay, in our industrial controls lab, of course, we have 3-phase power, so what we have here is 208 volts. Okay, so those actually go over here to these screw connections to tie into the bus bars. Okay, and then down here at the bottom you have your ground and neutral going into this connection to provide you multiple places to connect your ground and neutral. Okay, now let me just explain why these are tied together. Okay, so normally on a panel that you would be wiring, it's going to be much larger than this. Okay, even if you're looking at residential, commercial, or industrial wiring. Okay, the panel usually going to be a 200 amp main or more. Okay, this panel we just have in place for our lab purposes only, just to provide power. Okay, now you may see these in some applications. I know just from a residential standpoint, you could see these, say like in a garage, okay, where you want to have more than just one circuit. Okay, if you have power tools and stuff, you may need more power out there. So this would be a sub panel, okay, off of your main panel to give you more power and more circuits in a location. Okay, you may even have this, say in a basement or something, you know, off from the main panel, or a storage building. Okay, if you got a separate storage building and want some power there, you could use one of these sub panels. Okay, but for our lab purposes, it's acting as our main panel. Okay, so normally in a main panel, you're going to have up here a main breaker, so you can cut off everything with just that one breaker. Because this is a sub panel, low amperage, that's not necessary with this one. Okay, but that's why we do have our bus plugs to disconnect power. Okay, so also normally with the ground and neutral, typically you will have 2 separate bus bars. Okay, one basically that would be running on each side here. Okay, with the breakers centered and the bus bars on each side. One for neutral connections and one for ground connections. Okay, on this small sub panel, low current applications, that's not necessary. So they just have one bus bar for neutral and ground. Okay, so when you wire up your circuit, both your neutral and ground connections will go to this bus bar. Okay, your power, or your hot wires, will connect to the breakers. Okay, so you have 3 breakers here. Okay, you have 2 single pole breakers for 120 volt circuits. Okay, and we have 20 amp breakers here. Okay, so they're all in the off position right now. Move them this way to the right, and that turns them on. Okay. Up here you have a double pole 20 amp breaker. Okay, so that's to provide 2 hots to a circuit. So we'll use this on the project where you wire the dryer, which would be like a normal 240 connection. Okay, so you would use these again in residential applications for your dryer, stove, water heater if it's electric, also your AC system. Okay, you might actually have 2 of those if you have separate split system. Heating and air would also require this type of breaker. Okay, where you have 2 hot wires, but most of your circuits in residential will be just a single pole breaker. Okay, so just going to show you a quick demo on wiring this up. Again, there's 3 different ways you're going to do this wiring based on the project. I'll talk about the 2 alternative ways. There's one primary way that we're going to do this, but there's also 2 other ways. So let me just show you the main wiring that you'll be doing and then talk about the other 2. Okay, so we're going to take our Romex wire and run that to our breaker to get power for our circuit. Okay, so we're actually going to go up underneath here into the panel. Okay, and there you have what's called a Romex connector. Okay, or sometimes referred to just simply as a box connector. Okay, but it's basically a clamp that will hold the wire in place. I'm just going to show you here one I've got so you can see what that looks like. Okay, so you got 2 screws to actually tighten up this clamp to hold your wire. So your wire actually goes up through there into the box, and then you clamp this down, okay, to secure it. Okay, so I just wanted you to see that up close so you see how that works. So make sure on your panel, as well as any type of metal box, that you have those connectors to secure the wire in place. So we're going to run our wire up through here and attach that to where they need to go. But before you actually run the wire in, it's actually easier if you go ahead and strip the Romex off of the wire. Okay, that'll just make it easier if you go ahead and do that ahead of time. So in here you're going to typically need about 8 inches of wire. Okay, and a quick reference to use, I always use, is just my side cutters here. I can get them where you can see it. If I use that, my side cutters are actually about 9 inches, so that'll give me what I need. So I just hold my thumb there to give me my mark. Of course, you could always do this with a tape measure, of course, but if you take your knife and just circle around the wire, don't cut real deep. Just do a light cut and just kind of pull it off. It's really the easiest way to strip the insulation, okay, off of there. And then the paper, you just pull that off. So now I've got a good clean cut there and don't have to actually be digging around in here trying to cut that after I put the wire in.